So actually what we were discussing yesterday was the SIP trapezoid and how an invite message actually go. Remember, there are only two kind of messages in a SIP system. One is the invite, all other are actually categorized as a non-invite category. So this is actually usually written in capital, so let me put it. And other kind of requests will be non-invite requests. And most important thing is that acknowledgement is only sent for invite is a request, there will be a response, and then there is an acknowledgement which has to be sent. This only happens for the invite request. Okay. For non-invite request, there is no acknowledgement sent, it's always a request and response kind of thing. Okay. So SIP trapezoid, which I mentioned, was there is going to be a proxy server. I maintain two proxies there, and these are SIP phones or soft phones or any device which this is basically a SIP client. And most of the signaling will always happen through this route in the beginning to set up the connections. Once they both know each other's identity, they can do the talk directly. Okay. So this is the media transport technically, and of course signaling also can be done over this line once it has been set up. This is what we call SIP trapezoid. So initial case, if I put the timing diagram here, is the first thing which is being sent from this to this is invite. And that's what we were discussing yesterday, what this invite will actually look like. And the URI for this SIP client is this one. And you should actually appreciate that this is looks something like a mail ID, but SIP colon is something like HTTP transport URI. So it's a mix of SMTP or the mail addressing formats and HTTP. So in fact, this protocol was built because neither HTTP nor SMTP both were good enough for setting up the multimedia sessions. So a lot of things actually have been taken from them. So header format which we are discussing actually has come from HTTP. MIME type is common between internet messaging protocol as well as in HTTP both. Okay. So coming back to how the invite will look like. So invite, I think that's what we were discussing. This invitation is for this person. And it is doing SIP 2.0 format. If you put SIP 1.0, this is required for compatibility reasons. See, if you are a proxy and the clients can be actually implemented using SIP 1.0 or SIP 2.0, both. So since they are specifying in their request, so as a proxy server which you are going to implement, you can figure out the request corresponds to which kind of client, and based on that you can choose a different behavior in responding back. Or you might actually do what we call again a gatewaying kind of thing. So you talk the client which is connecting to you is with 1.0, but onward you would like to do 2.0, so you do all the translations. So that capability also can be built within a proxy. Okay. Usually it will be implemented as back-to-back user agent client. That's what is known as actually BUAC. So proxies are again of two kinds. I have not specifically mentioned. So these are stateless and stateful. I will explain what does that actually mean. or maybe I can explain that. So one kind of proxy is that this is a user agent client, it maintains all the state, it goes to the proxy. Proxy understands everything about it. So it keeps the complete track of this transaction which is happening with this, maintains the whole state, and on his behalf then he does the communication further. So this is maintaining the state of the transaction. That's a stateful proxies. Okay, that's a stateful proxy. So there is a server sitting here, there is a user agent client, user agent server, and there is another user agent client which is communicating further. So there is a data structures which are maintaining the state. While in stateless proxy, state of the transaction is not maintained. Stateless proxies so here user agent client passes on the message. What it does, simply receives the request, changes whatever is required, adds the header or whatever it is, and transports it further as it is. It does not maintain the status. So when the response will come from the other side, it will send back the response. It's as good as that actually. So the proxy which I am talking about here is stateful proxy, not stateless. So stateless proxy also can exist.
So what is the advantage of stateful proxy? Because here
mostly we will be implementing stateful only. Stateless cannot keep, for example, it cannot send an OK. I am still trying the connection further. Okay, so it will not send the signal back, for example, that 100 thing, which will say I am still trying, kindly wait. So the first line will be this, as I mentioned. Then there is a via header field. Via header field tells that for this particular request, remember a request will have at least one response, can have more than one response also. So you send a request, one response comes, then there can be multiple responses, but at least one response has to be there. Okay. This via field will tell that who is sending, and this is what is going to be used when the return response will come. It is going to come via this. That's what it actually means. Okay. So in this case, it gives the complete transport, the SIP version which is there. So the user is actually sending the invite through this particular client. So actually message, the response should come back to this particular client. That's what it means actually. And this will then communicate back to the user. So that tells the machine which is sitting in. There can be multiple, remember within a single machine, there can be multiple user agent client running simultaneously. That's possible actually. So you have to tell through this machine only it has to come. You cannot give your own address. So that's why you are giving an IP address there, and the machine will decide how it has to be handled. And what is this PC33 is nothing, as somebody asked yesterday. In the domain name system database, this PC33.atlanta.com, when this you will do a DNS query, domain name service query, it will give back the IP address of that machine to which the response has to come back. This machine is currently the give the DNS name for the soft phone used by Alice in this case. Okay. And then of course there is a semicolon, branch, and then there is a random string. I put something here. So this is This for identification purpose actually. This for identification. And then after that, and you have to understand the first letter is always capital for the field attribute, and the attribute's value will come after colon always, and these usually will come in one line, most of the header fields. And next forwards is for how many times this request which is being generated can be forwarded further. So because SIP proxies can keep on doing handovers, but how many times? So each time you do forward, you reduce this number by 1. When it becomes 0, you no more forward it. Okay. And this is like time to live field. 2 is the destination to whom the invite has to be sent. You are trying to make a phone call to Bob, so Bob's address has to come here. Now this first character is usually known as display name. This is actually the name which will be displayed to user. It's not actually the URI. This is also being used in your email systems. So you write your name, your phone number, whatever it is in your display name. Email comes later on, and that comes in this angled brackets. So this is very similar to email. Angle brackets will close. Users will usually get, this is your arbitrary thing, and there are of course rules for setting up this particular thing. So this is again given in internet message format. There is an RFC which is uploaded on Brahaspati. In that this is given, or you can look at it from IETF. Okay. There is a from field correspondingly. Always the first character is capital in all the field names. Now there is one more important thing which will come here, is a tag. So if Alice is simultaneously making multiple phone calls, that's possible. It might have set up multiple sessions, each time a tag will be different. Bob might be receiving multiple sessions, so each time a tag will be different for each session. So in fact currently there is no tag because this is the initial invite. When the response will come back, a tag will be added by the Bob, and this tag will be simply replicated till this dialog will exist. For this particular call, this tag will be just simply replicated everywhere. In the beginning only the Alice machine will be choosing this, is randomly generated by soft phone. Okay. So in this case I have just put some random number. So these two tags can uniquely identify Bob and Alice's soft phones. Now there is only problem is that we need to also identify the third entry, because Bob may not be using one phone but multiple phones simultaneously. So he might be using a voicemail box or something else. So there is a possibility of actually using same tag. If it is same machine, it can be assured, but otherwise it cannot be.
This tag is generated by
soft phone.
Soft phone of Alice or Bob?
This one is by Alice. Bob still has not received the invite message, so there's nothing there. Only when he will respond back at the time, he will add his own tag. It's a random string generated. It's not a sequence number. It's not incremented. It's soft phone's local feature. Internet standard does not bother about it. Okay. Then you will have call ID. This usually is a random number and the machine IP address which is being actually used. So in case, because we have a DNS name already being assigned to this source, which is pc33.atlanta.com, if it is not there, you simply use an IP address. Okay, dotted decimal notation, IP address has to be used in that case. So in fact, there is no need to always use domain names. You can actually use IP addresses, that is permitted. So call ID usually will be some random number generated by this random string, but that is not good enough. Now this is going to be unique, nobody else can generate it, because this call was initiated by this IP address. It is generating the string, it can maintain what all sessions is running, it can ensure that this ID cannot be generated by anybody else in the world. This is a unique call. The way in TCP IP connections we always use that quadruplet: source IP address, destination IP address, source port and destination port, and that's a unique all across the world. All TCP connections which are working at any point of time, none of them will actually have all 4 set values which are going to be sent. That's not possible. Same is also true with this. So in fact, this particular tag and another tag which will come once the call is set up or in the response to this, these 3 things together, if you put this triplet, is unique, always unique. So this is actually redundancy built into the system, you can observe that actually. And this uniquely identifies a call. This uniquely identifies a call.
All 3 random.
And so all these 3 random numbers put together identifies something known as dialog. In earlier RFC SIP 1.0, this was we used to call it a call lag. Okay. So now this call lag is not there, it's now we call it dialog. Okay. Then of course C sequence. Interestingly, I am using UDP, but I need reliability in the system. So sequence numbers of the messages is extremely important, or the command. This whole thing is one command going in one UDP packet. Okay. But if it is lost, then what you will do? You should get a response within certain time, then you will retransmit it. Response can come multiple times. So important thing, if I send first command, I will put a sequence number. When I send the next command, I will change the sequence number. This is known as command sequence. So again, this is for reliability purpose, so that you can figure out the duplicates. And all the responses, when they will come back, will just duplicate this, whatever is the value of this particular attribute. So in this case, there is some number which is given. The command is invite. So this invite, this command will keep on changing, sequence number will keep on upgrading one by one. And of course the contact. This is not the SIP URI of the sender, this is actually the actual URI at that point of time. So when you, for example, don't send an invite, you send a register message. So this will consist of register. It will be sent to a registrar by your phone whenever the phone boots up. Okay. So it will give the registrar's URI, whatever it is, everything will come. The contact, some fields will be there, some will not be there. The contact field is what is going to be registered. So from and contact, these two together will form the binding in case of a registrar. Because what will happen, your domain proxy server will have your URI, does not mean that it can contact you. Your contact at that point of time will be your actual machine address which is going to be used. So here it is currently written as, and this can keep on changing actually, depending on if the LS keeps on moving, IP address changes. So when the response will come, you are telling the receiver that the contact is this for the sender. So you can, once he understands this, authenticates everything, he can directly get in touch here and starts talking actually. Start doing direct point peer-to-peer signaling. Of course, the worst thing will be generate all this header and contact you for somebody else. So when peer-to-peer connection happens, you might be talking to a wrong person. That's actually possible, but that is taken care of by the authentication, challenge response method. But what will happen is if the alias is proper, and for this can authenticate with the proxy server can authenticate alias. So whatever alias is telling as a proxy is the actual contact at that point of time where the call has to be made. It must be justified. If I authenticate you, you say for all your letters should be dispatched to him, it's fine, I will always do that because I have authenticated with you. There is nothing to worry about. If I don't authenticate, then there is a problem actually. Then somebody else can need not even create a client in your name, it will have his own client, but may send a request in your name and then I can start peering with somebody else. So spoofing can happen in that case. But security is currently is not discussed. Security is a separate thing, as I mentioned earlier also.
In case of multi-user on the same machine, sir, from and contact both will change. Multi-user on one
Yeah,
machine.
both of them will change. Only this IP address will remain same. You will have multiple bindings pointing to the same machine address. So machine address is only this part. There is a SIP URI.
This will change. This will change.
Yes, SIP colon and the names will keep on changing. SIP colon will remain same and IP address remain same. If multiple users are there on the same machine, same soft phone. So bindings will keep on changing. You can actually have even a binding like this for same URI, same SIP URI. You are going to have multiple different devices can be actually, multiple different contacts can be there in the registrar. But currently I am not looking for the registration process. That is also permitted. So when a proxy will get a request to connect to some SIP URI, and then it will look into the location server, what we call registrar. Registrar only what it does, a SIP URI comes in and it maps onto certain other SIP URIs. Now this SIP URIs are dynamically changing depending on where you are connected or where your soft phone is installed or who is registered with that. This address will keep on changing. But remember, your identity here remains same irrespective of where you are. So this dynamic mapping from here to here, if you are going to go, that is done by registrar or location server for the destination site. For receiver you are telling actually. So far you can authenticate well with your proxy and proxy can take up a request on your behalf. He can set up the connection then directly peer to peer. So if you go to your friend's office, you can actually make the registration from his machine and then you can start getting calls there. Very simple way of doing the call forwarding actually. But that's through a register, not through invite. This is invite structure. So after the contact, you will have a content type. This is typically what you will see in the HTTP response or a message. So since invite will contain a session description message, so SDP technically is not a protocol, it's a format in which the session description is written. But we still call it a protocol. Protocol is nothing but set of rules to be followed. Okay. So there is no FSM in case of SDP. There is no finite state machine. So in this case, you will say it is an application type SDP. I can say application oblique PDF also, not an issue. So I can use SIP to submit a PDF to the remote site. I can communicate peer to peer. File transfer if you want to do, you can do this way. It does permit that. It will not avoid. So you can, this typically is required in internet messaging. You can actually use SIP for doing messaging. Sending SMS for example. So ISUP and SIP. SIP technically is now being used in 3G and higher end system actually. So there, this is what will be used for transporting your SMS or text messages or PDF files. SIP does not bother what's going in the payload. For him, it's a opaque object. Opaque means it does not see through the object, it does not know what's there. It only knows there is an object, a certain number of characters. So this application type, that's what will be used on the receiver client to figure out what applications are required to understand the content. If you write application/PDF, that client must be maintaining a application list. Whenever application/PDF come, the content has to be viewed by a PDF viewer. Whenever application/SDP has to come, a SDP processing component has to be there in your media client, which will understand what is there in the SDP. Okay. So protocol does not bother about what's there in the content. It's only transferring from one person to another person, and these has to be correct persons after due authentication process, opaque object. That's the way it is termed as. And then of course the most important thing, content length. So some number, I think this is basically octets. Remember, all this is always going to be, it's not ASCII or ISCII, this is all UTF-8 encoding which has to be used. All characters has to be UTF-8, so you can even send text in Hindi, nobody stops. So you want, you can write your SDP in Hindi language and send it, it's permitted. It's not ASCII text, it's UTF-8. Okay. So in fact all these things can be put in UTF-8, nobody stops. Even URIs can be defined in UTF-8. So you can write your name in Hindi @ a Hindi domain name. Those are now permitted actually under internationalization. So UTF-8 is the standard all across. So multilingual, and then of course important thing, there is a blank line, we call it carriage return and line feed, CRLF. This actually has been taken from HTTP. After the header there is going to be carriage return and line feed. So carriage will be, you will do a carriage return, you will come back and you will do a line feed. There is a one line gap which will come, and after that whatever characters are there, 142 characters from here onward, this length 142 characters is what is your SDP text, which has to be taken out by the receiver and has to be analyzed. Okay, so this we call
line is basically to demarcate between this,
demarcate between header and payload. So header ends here, that's the indication. So there should not be any blank line in between. There has to be always a character. That's important. So there is a SDP content. Not shown. So this is that 142 characters. That's what a typically a message will look like. So now what will happen is, as the invite has been sent, I am now writing down the numbers which you were asking what does they mean. So this will say trying. So 100 is not final. Invite is a message, invite is a request. In response to that you can get multiple responses. So this is the first response, you will get more of them actually before the invite is, response is final. So trying is you keep, still hold on. Okay, so don't time out. You have to keep on sending trying periodically so that timeout can be reset. Otherwise it will time out and send another invite. Okay, it's to reset the timeout clock. So this is typically designed for the, because their timeouts actually can happen over a long period. And then of course there is a longer path and everything. So there is always an acknowledgement which also has to be sent back. That's why I said that invite is the only kind of request in response to the response of the invite. Only in this case you will send an ACK, not for any other kind of request. So invite will be forwarded by the proxy, it goes to this one. This will further send an invite to him. This is again trying. This guy's phone is free, that's my assumption here in this case, so phone will start ringing actually. Phone starts ringing, you will send 180. So trying, ringing, all these are with 1XX series actually specification. So this ringing, once it reaches here, it will be sent back further. And you can see this is very similar to signaling which is used in conventional telephone, similar structure, but with slight variations now. Once the guy picks up the phone, 200, he is willing to communicate. So still connection has not been set up, call is not through. 200 okay, because acknowledgement also has to be sent back, remember. So once you lift, you are willing to take the call, you will be waiting, still call is not through. So that also happens in telephone exchange, ordinary conventional circuit switch systems. But it happens so fast you don't realize that after lifting your handset, at the receiver end, the signal is going back till the source and it's disconnecting and the voice circuit is being connected, because that guy is also getting a tone back, a hunting tone or maybe a ringing tone. So that has to be stopped, a voice circuit has to be connected. So all voice path actually has to be cleared once the confirmation happens. Here still there is no voice path as of now. They have only started, the moment OK is happened, whatever has been sent in the OK, this particular field, there are header fields and payload again in this SDP. It has already got a received, the SDP which has been received. It is now know what are my capabilities, it is sending another SDP. SDP as session description protocol will tell what kind of codec is going to be used, what kind of bit rate, port number, whatever it is. So this phone at least by this time knows that the common between the common subset of the two SDPs is what? Communication is going to happen on that, those terms, is negotiation now. Okay. So this guy asks for a higher bit rate codec, but that codec is not available, you get a lower one. So it will just simply know the other guy will also have to choose a lower one. There is nothing like your own choice. Whatever is the minimum of the two, you have to choose that. So it will choose, it will start the media service on that. It will start accepting the voice call and transmission also is permitted actually. But still call is not through because this side client is still not configured itself. So this will send OK. $200 OK. This 200 OK also happens in HTTP, by the way. Actually same status codes have been used, what is used in HTTP. Except some of the numbers are different because ringing does not happen in case of HTTP. This is only a function in SIP. 100, I don't think it's there in HTTP because there is no proxy forward actually. So once this 200 comes, then by this time this guy knows that how the response has to come back. Remember in this case, a via header was inserted by this proxy. In the initial invite which was sent, there is only one via header. By the time this guy actually has forwarded the invite, another via field has been inserted here, which says via SIP/2.0/UDP, whatever is this domain name of this entity, and then semicolon branch some number, random string corresponding to this dialog. So in the reverse when it comes, it can match actually. When the response is coming back, this guy can figure out it's matching with which particular entity. Because so far, in fact even this tag and this can be used, but dialog is not fully set because this is not known response. It's putting its own tag value. So these three combinations for this proxy now uniquely identifies the dialog for the time being. So that's why in the VI field it has been done.
So invite and other, 100 and 180 will also contain the.
They will all contain headers, and they will also can contain payload.
But
So I will come to the structure of, for example, this 200 OK. 200 OK message, I am going to come for that. So there is a VI field which is going to be added here. And this will be something like big box, whatever the DNS for entry for that thing, site3.atlanta.com branch. This is the invite when it comes out from this machine. Previous version of the invite when it started from here. So another VI field is added here, and some number which will come Z9H, whatever it is maybe a different string than this, need not be same. This is function of the machine which is starting the invite. And remember, this is stateful proxy currently. Both of them are stateful proxies. Stateless proxies don't do this. Yeah, thing. Similarly, when this guy actually will send, it will add another VI field here. So this will also say SIP 2.0, its UDP, and server 10.veloxy.com, and then of course a branch, a random string sitting in here. Okay. So when this guy is going to send the response back, any ringing, okay. So this, for this particular request, all responses has to be sent in this fashion. Not for the complete dialog, remember, not for the dialog. Okay. So dialog, there is another field which has to be added by these. For example, this guy wants in later on, for this whole dialog, whatever transaction has to happen through me. It has to send something called record route, header field in that case. So currently there is no record route. Only the response to this invite will be sent back to this guy. So once it is coming back, then this VI will be removed. So for this only, this VI will be available, so it will send the response here. That's why this trying 180, everything is taking hop by hop. They are coming in the backward direction. If this VI would not have been added, for example, this VI and this VI would not have been added, then what would have been the situation? Simple thing. That ringing thing would have directly come to this guy. No intermediary in that case.
In that case, it will take in the bottom path. The bottom path.
Which one? No, currently everything is multiple hop, everything is through VIA, because all these three are response to the same invite. This invite request is not over with one response. It requires 3 responses to complete the request. There are intermediary responses which are coming. I have only told a request requires at least one response. It's only at least one response. It can have multiple of them. That's perfectly all right. So there are 3 responses here. Okay, and this VIA field is every time added by every proxy. And I allowed how many forwards? 70. So there can be 70 VIAs which can be there. It means the request itself will take a lot of time, and response itself also can take a lot of time.
Sir, how is this route decided?
This is, for example, you yourself don't know about where the destination is. Usually you will always forward the request to whichever is a proxy server registered for you. So in your phone it must be configured. Or when you buy an IP phone, you know my service provider is this, so you will put his proxy server's address. You will log in, authentication, you will do a registration there at your registrar, and you will get the proxy server also. Usually proxy server registrar will be co-located thing in the same machine usually. But logically they are separate entities. And then you don't bother about how it will be routed. Just send the invite to this. This guy will now look at the SIP URI of the destination. It has to talk to somebody called bloxy.com. So it will make a DNS query. How the mail is sent, for example. You want to send a mail to some xyz@bloxy.com. So your mail only goes to smtp.iitk.ac.in. So this SMTP server then actually try to look at DNS record which corresponds to what we call MX record, we call it mail exchange record. A DNS can contain multiple kind of record. It can simply be I gave a machine address, what is the corresponding IP address. That's one kind of DNS query. I can ask within a domain what's the corresponding mail exchange record, MX record. So when you want to send a mail to Gmail, for example, our machine will then try to make a query, DNS query to domain of gmail.com. So gmail.com DNS is not known to him, so it will go to root server, dot servers actually. There are servers which are listed, it should be known to everybody. In a root, servers for DNS are always configured in every machine and they are periodically updated from the main server. Okay, so these are again maintained by the Internet Authority. Internet Assigned Number Authority, they actually take care of this. INA we call it, or INA, IETF, everything, they are part of ISOC, Internet Society. So it's ISOC's responsibility to do this, and it works on donation, no government funding, nothing. ISOC works purely on donation and voluntary efforts. So you go to the root, from root you will find out I have to go to gmail.com, so where is a .com server? So you will find out for .com there is a DNS. In .com everybody who has got whatever is named .com will be listed in that server. So I will go there and gmail.com will be searched there, I will get a gmail.com's DNS server. In that server then I will make query what is the MX record for your domain. It will give a IP address where I am supposed to now do a SMTP connection and do the mail transfer. Same way for bloxy.com you will ask for what is the corresponding SIP server in your domain. Every domain will have one or two SIP servers. So one is the main, other one is a standby, backup server basically. So once that DNS will tell this is my server, this guy will talk to him. And it is now purely depending on the DNS is giving the proper information, it has not been tampered by anybody. Once you know this, you will say you are a MX record for so and so, can you give me the security certificate for that? This could be one security mechanism. And say I am so and so. But this guy will say, how do I know that you are so? You also show me your certificate. Both of them will do the security certificate based authentication for each other. They know each other. Then it will send an invite to him. This guy, it is there in his domain only. Through registrar location server, it will find out if the guy is there or not there. Make a connection. And then before making connection, it can authenticate you are the right person or not. I issued you a certificate, show me, through that you authenticate. This guy can authenticate again using security certificate, this thing. Or it's a challenge response. For every transaction, you will say give me your user ID and password. When you do, for example, browsing through proxy here, what happens? You don't actually give login password in the beginning itself. Just type out your URL. Once you try, then suddenly a window pops up from the proxy. Proxy sends a message, you are not authenticated, give me what is your username and password. Once username password comes, you will enter that. Your browser actually stores that username password for that session in the memory. Now for every HTTP transaction, there is two fields which are added in your HTTP header. These are known as HTTP user and HTTP password, proxy user and proxy password. So every HTTP transaction from that onward when the browser sends will also send these two strings, which then the proxy will match and authenticate. So challenge response, this is what we call challenge response method. You don't give your login password immediately, you just try without that first. There is no match, those fields are not there, it will respond back. Or if you give wrong entries, then also it will respond back and ask for that credential. but unfortunately this goes in HTTP header, and if you are not using HTTPS, this goes unencrypted. So if you can sniff in between, you can actually get a user's password, if it's possible. So ITK, it is actually possible. A lot of people still use HTTP and they use proxy. So it's technically possible to do the sniffing and get the password. Telnet also has similar problem. In fact, we always say don't use Telnet because of this. But Telnet, one good thing is it's only in the beginning itself only the login password goes, and that's it. But with HTTP, it's not only in the beginning, it goes with every HTTP request. That's the bad part. Okay. So now coming the response structure, how it will look like. So let me just complete this diagram first, and then after this the acknowledgement has to go back, and this goes directly. This never goes through this multiple hops, because by this time it already knows where you need to contact this guy. So when I will tell what is the structure of OK field, you will understand, because the contact, the way you had a contact here which gives the currently active thing, so this contact of this this destination will be available with him, and this guy knows the current contact of this, so they can now directly talk to each other. This via field only gives where the signaling information has to come back. It does not give where the media has to be connected. This is given here, direct peering between the two clients. So ACK is always sent back here, and then of course depending on the SDP you can start transmitting your voice. There is no ACK or whatever it is, you keep on streaming your voice from here, this guy keeps on receiving, this can also keep on sending his voice, you start receiving, you start playing back, and that's how the communication will take place. So UDP packets will flow between the two endpoints.
So what is the purpose of ACK?
What happens is it's a reliability mechanism here. It's only built for invite. So you have done all acknowledgement, OK, everything. This has to send back the ACK, and ACK will replicate most of the fields again.
The question is just when he invite message reaches at the other end, user client, he know the IP address or what and SIP URI through invite.
But this guy does not know what is the IP address of that guy. OK has to come back all the way.
Okay, he knows the SIP URI but does not know the IP address.
Yeah, does not know the contact. Contact cannot come till this OK comes back here.
Contact means current contact.
Current contact. What the machine?
Machine, IP
What's the
address.
current machine?
Okay.
So remember there is a SIP user client and SIP user server. User USE user
UAS.
and UAS, user agent client and user agent server. They both are running on with every client. So this is a user agent server which is going to run here, user agent client, and they can directly do the SIP transaction also. But they don't know each other's actual locations.
So what information goes inside the ACK? What information goes?
It only acknowledges that I have received this OK, now our session is active. Because it takes quite a long time, because you can actually have to do multiple hops. And this may take a different route altogether. So you have to first of all do a signaling to a machine in US, this guy will do a signal to somebody in Russia, then it comes to somewhere else, then to somebody in China. So, but when you actually start sending ACK or the media, you are directly peering with your friend. These signaling entities are not participating there. They need not. It's a peer-to-peer connection. Except in the case where you require media gateways or where you require intermediary proxies, media proxy actually, for doing tapping.
So we have done the media negotiation parameter in SDP.
You have already sent in the invite an SDP. In the return OK also you are going to get an SDP. So these two SDPs, the minimal of these two sets is what is going to be accepted by the two. Minimal of these two.
It's coming from.
For example, this guy says I want a studio audio. Okay, it has to have 8000 samples per second. It comes here, this device sends in the SDP, it does not have capability of stereo, it can only do monophonic. It can say monophonic audio, and probably 8000 samples is too high for me, I cannot do that, I will work at lower rate. It can do that. So this can work at the lower specifications. So whichever is the lower of the two, that will be used, agreed by both. Offer acceptance kind of
So
statement.
at what time, at what point the agreement
Agreement happened at this point itself.
is?
It already knows the SDP which is coming, and whatever is agreed upon stuff, that SDP is going to send back.
That agreed information sent to only.
Okay. And there are certain things which always has to be there. The certain codecs have to be there, available with every peer client, because there might be a possibility whatever it is offering, it's not available here, then call cannot be set up. It will simply refuse in that case, if meshing does not happen. All media you may not be able to handle. Well, I can give a very nice example. We have a Brahaspati Sync client. It is for live lecture streaming. I require chat, I require whiteboard, I require audio, I require video. Video and audio are in multiple layering. I define that and send it here. This poor guy is nothing but simply a soft phone. You are trying to listen to what I am speaking in the lecture over a phone. You can only receive audio, you cannot receive video. So you will say, I can only receive audio, there is no layering required, I cannot handle chat, I cannot handle whiteboard. So that's what I will get. So I will only do audio streaming all the way to this guy, and all other medias will not be sent to the person. So but still the person will be able to listen to my lecture. Some person can say, I don't have much bandwidth, or maybe what can happen is, in between the bandwidth, congestion has happened in the network, bandwidth is very poor. The video should not be sent actually. So any one of them also, they can modify the current session parameters. They agreed for the video part, then one of them can ask for a video drop. Then I can do a media drop also. But remember, it's a peer-to-peer direct connection. Brahaspati Sync does not work on this principle. It's a peer-to-peer overlay multicasting.
You say midway we can modify.
Midway we can modify. We call it a re-invite. But remember, the message here still will say invite. There is nothing like re-invite, there is only invite. But it's a re-invitation. And how it will be, people will identify it's a re-invitation? Because these two tags and this will still remain the same. If they are same, I am still talking about the same dialogue. It's a renegotiation.
There will be no midways in the re-invite. In the case of re-invite, the
Dialogue must be already existing. There is nothing like re-invite. The keyword still is invite. You can send another invite midway in the session for the same dialogue. Then you are renegotiating the parameters.
Without call being set up.
The call is still running.
Running.
Call is already running. If it is accepted, both of them will switch over to the new parameters. If it is rejected, you will still remain with the older parameters. Call will not be removed. Call will not be terminated. Midway negotiation you are doing, you can keep on doing it multiple times till you find out something which is suitable for both of you.
So midway, how we do the authentication if we are changing the parameter?
Authentication challenge, this protocol does not bother about authentication. When you send HTTP, you are not sending login password, it will again send back the information. Then you have to attach the login password and authentication will happen. So now only thing which is left is the reverse direction, the OK part, and then of course lot of other features which are there in the RFC. So we will continue with this discussion. I think I have now 4 more classes left and we will devote only to SIP, most other stuff, so that I will also learn in that process in more great detail what the SIP is all about.